Welcome students in the series of lectures in the subject VLSI design. Today we are starting with design of testability. So we have a fabricated chip, okay? Whether this chip is fully functional, the task of determining this is very complex. And if not properly done, it can be very timely consuming. It is great importance to detect faults as early as possible. Okay. Now there are various fault types and models. So chips testing is usually multi-purpose and basically it attempts to detect faults in the fabrication process, design process, and failures due to the stressful operating conditions. Input test vectors are devised and applied to the device under test or the circuit under test. Then the measured output is compared with the expected output to determine whether the device under test is good or bad. Okay. Now physical defects. Defects are basically classified as physical defects, electrical faults you can say. Due to the consequences of the physical defects, various faults takes place, and due to these electrical faults, corresponding logical faults takes place. So, what are the physical defects? So, physical defects are basically in the silicon substrate, photolithographic defects, mass contamination and scratches, process variation and abnormalities, oxide defects. These are the physical defects. Due to these physical defects, these may lead to the electrical faults and logical faults. So, what are the electrical faults? Electrical faults are shorts, open, transistor stuck open, resistive short open, excessive change in threshold voltage, excessive steady state current. These all are the electrical faults. Now, what are the logical faults due to these electrical faults? So logical faults are logical stuck at 0, stuck at 1 fault may occur, slower transition or delay fault may occur, and bridging or bridging may occur. Okay. So let us try to understand all these faults by considering this example. Suppose we are fabricating a two input NOR gate. So this is the layout diagram of a two input NOR gate. So here, at the time of fabrication, this defect has occurred. Okay. Now this defect is basically there is a short path between ground and the drain terminals of the NMOS transistors, common drain terminal. So this defect can be anomalous in the electrical fault model. Okay. So electrical fault model, it can easily be seen that this physical fault leads to this electrical fault, means a resistor is coming here. Okay. Now this is known as resistive short. Okay. Now due to this resistive short, logical fault may occur. So how this logical fault will occur? So if the value of this resistance is very low, if the value of this resistance is very low, so if the value of this resistance is very low, so it can be worked as a short circuit. Short circuit. Okay. So if it is working as a short circuit, then the output will stuck at 0. Okay. It will not depend upon these values. So this is stuck at 0 volt. Now if the value of this resistance is very high, okay, if the value of this resistance is high, okay, so in that case stuck and what fault may occur. Okay. So these are the stuck at 0 and stuck at 1 faults. Now let us consider another example. So here in this example we can see that uh, due to the fabrication process, if there is a connection that has been made between the supply rail and the B line. If there is a connection by mistake, it has been made between the supply rail and this B line. So whatever value you will give here, 1 or 0, this B line will always stuck at 1 because it is connected to the supply rail. This is known as a stuck at 1 fault. Okay. Now consider this transistor, PMOS transistor. So in the fabrication step, in the fabrication of this PMOS transistor, if the drain and source terminals are pretty much close to each other, or by mistake drain or source terminal has been shorted, so this is a permanent connection that has been made between drain and source. So this is stuck on, this transistor has been stuck on, this is stuck on fault. Okay. Another, let us take example of this transistor M2. Okay. So in this case, in the fabrication process, if the distance between drain and source is very high, or uh, the distance between drain source and gate terminal is very high, so whatever voltage you are giving at the gate terminal will not affect, will not form the channel here. Okay. So this is stuck off, this is always stuck off. Whatever value you will give at the gate terminal, it will not affect it. Okay. Another type of fault is the bridge fault. Okay, bridging fault. So in the, as you know, fabrication process in VLSI design takes place in a very small area. Okay. So these lines are basically at a very close to each other. Okay. Here in the circuit you can see these lines are separated, but in actual situation these lines are very close to each other. Due to the fabrication failure, there may be short between these lines, so this is called the bridge fault. Okay. A bridge can be created between the input and the output. Okay. This is called the bridging fault. Okay. In addition to these type of faults, uh, we also have delay faults. So delay faults can be due to improper estimation of on-chip interconnect delays. Interconnect delays we have calculated. So if improper calculations of interconnection delays is done, then it may lead to delay faults. Delay faults can also be due to excessive variation in the fabrication process. If there is some open part in the metal lines that connect parallel transistors, then delay faults can also occur. Aging effect also lead to the delay faults. So these were the delay faults and models that we discussed. Thank you.